And now we'll do this a little bit slower. Okay, the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, I have some important messages for y'all. Today, we're going to be reviewing for the Chapter 9 test, which is due by Monday evening. You can take it anytime up till then, but remember, once you start it, you only have 90 minutes to complete it, but it has to be finished by Monday night. On Monday, we will not be meeting as a class. There will be no 10:30 a.m. Zoom meeting, all right? Tuesday is advising day. So there will be no classes, no Zoom meetings, no office hour, not a zilch, okay? So after today, the next time that we will officially meet will be Wednesday morning at 10:30 a.m., okay? Now, you can come back this afternoon to my office hour, but Monday, no class, you just take the test. Tuesday, no class, advising day, back on Wednesday. Any questions about that before we go on? Okay, so we're going to be reviewing for the Chapter 9 test today, and I have lots of questions people wanted answered. The good news is we've got the whole class period to answer questions. That's all we're going to do. So I'm going to get started. Let me see here. I need to switch screens, and we'll take a look at this screen. And we're going to look at, this is from section 9.5, number 15. It says, solve the equation for the indicated variable. So we have R equals the cube root of the quantity A divided by P, and then outside of the radical minus 6. And we are to solve for P. Okay, so let's go back to my whiteboard screen. P is inside the cube root and it's in the denominator. Before I cube both sides of the equation, I want to isolate the radical. So my first move is going to be to add 6 to both sides of the equation. All right. Now I'm going to cube both sides of the equation. On the left side, I'll get R plus 6, the quantity cubed. On the right side of the equation, I'll get A divided by P. Any questions so far? All right. Now, I'm trying to get P by itself, not A. P is in the denominator. What I'm going to do is I'm going to multiply both sides times P. That will give me P times the quantity R plus 6 cubed equals A. But again, I'm trying to solve for P. So now I'm going to divide both sides by the quantity R plus 6 cubed. So I end up with P equals A divided by the quantity R plus 6 cubed. Now, I hope you didn't take the R plus 6 and multiply it all out. I suppose you could, but it wasn't necessary. We all right with that problem? Any questions there? All right. Let's see. Now we're going to go to the same person's questions, but the chapter review. And so number 8. All right. So this is chapter 9, the chapter review. And we're going to look at number 8. It says, find the domain of the function. Enter your answer using interval notation. And our function is g of x equals the square root of the quantity x plus 12. Okay. Now, the function involves a square root, that is an even root. You can't take an even root of a negative number. That means that the radicand, the quantity inside of the radical, cannot be negative. Therefore, this quantity either has to be positive, that is greater than 0, or it could equal 0. So basically, we're taking the entire radicand, and since it's an even root, we're going to set it greater than or equal to 0. Then we're going to solve this inequality by subtracting 12 from both sides of the inequality. And finally, write the answer in interval notation. X is greater than or equal to negative 12, so it starts at including negative 12 and goes on to infinity. So there is our answer. Any questions about that problem? All right, we're going to go on, continuing in the chapter review, and take a look at problem number 12. It says, evaluate the radical expression, if possible, without using a calculator. If the solution is not real, enter not real. And we have negative the fourth root of 2401. Now, first of all,
really quick.
Yes.
This number 12 in the chapter review or 9.5?
We're still in the chapter review.
Okay, awesome. Thank you.
No problem. Sorry about that. Yes, these next few questions still in the chapter review. All right, now we're taking an even root, fourth root, but that negative sign is outside of the radical. So it's not like we're taking an even root of a negative number. That negative sign outside will be applied later. Okay. So I want to figure out, is 2401, is that something to the fourth power? So I need to figure out what goes in to 2401. And this is going to be a calculator problem. It's not even, so 2 doesn't go in. If I add up all the digits, 2 plus 4 plus 0 plus 1, it adds up to 7. 3 doesn't go into 7, so 3 doesn't go in. It doesn't end in a 0 or 5, so 5 doesn't go in. How about a 7? Let's see, 2401 divided by 7. Oops, it helps if you turn your calculator on first. 2401 divided by 7. This is 7 times 343. And 343 divided by 7 is 49. Oh, so I've got 7 times 7 times 7 times 7, 7 to the fourth power. So 2401 is 7 to the fourth power. So basically I've got this situation. Well, remember the nth root of a to the n equals a if a is greater than or equal to 0. So we're taking the fourth root of a fourth power. So the radical is going to become a 7, and the negative sign outside gets applied. So the final answer, negative 7. So that took a little bit of work determining what number went into 2401. We good to go on? All right, this is number 27. We're still in the chapter 9 review. And this says, simplify by combining like radicals. The square root of 72 minus the square root of 98 minus the square root of 162. So the way we deal with this kind of problem is we simplify each individual radical. Since they're all square roots, I'm looking for perfect square factors. Well, 72 is 2 times 36. 36 is a perfect square. So the square root of 72 would be equal to the square root of 2 times 36. But the square root of 36 is a 6 outside, So I get 6 square roots of 2. All right, minus the square root of 98 would be the square root of 2 times 49. 49 is a perfect square, so I've got 2 times 49. The square root of 49 is 7 on the outside with a square root of 2 still inside. And then finally, 162, let's see, that's 2 times 81. 81 is a perfect square. The square root of 81 is 9 on the outside, so I get 9 square roots of 2. So these, all 3 of them are like radicals. They all have the same radical part, and that is the square root of 2. 6 of them minus 7 of them would be -1 of them. Minus 9 more of them would be -10 square roots of 2. Let's see. That takes us to here and there and 9.5. Again, I ask you, if I do a problem that's the exact same numbers that I did before, please let me know. Okay, I see. This one is very similar, ever so slightly different. Okay, we good to go on? All right, so now we're back in section 9.5. This is also number 15, very much like the problem we did earlier, just slightly different numbers. The previous problem, let's see here. Did I show the WebAssign screen? I don't know if I did or not, so I'll just go back. And this one has a -8, whereas the previous one we did had a -6. It's going to be basically the same thing, same steps. That is, R equals the cube root of the quantity A over P minus 8 outside, and we're to solve for P. Okay. So I'm going to add 8 to both sides of the equation. R plus 8 equals the cube root of the quantity A over P. Okay, here. I'm going to cube both sides. So I get R plus 8, the quantity cubed, equals A over P. I'm going to multiply both sides by P, which gives me P times the quantity R plus 8 cubed equals A. Then I'm going to divide both sides by the quantity R plus 8 cubed. And so I get P equals A over R plus 8, the quantity cubed. And I think the previous one was R plus 6, the quantity cubed. So basically the same steps. Okay. Now we're going to go back to some chapter review problems. And let's see here. Number 7. Okay, we good to go on? So this is chapter review, chapter 9 review. And this is number 7. It says, simplify the expression, all variables represent positive real numbers, which means that we don't have to worry about absolute value bars. Since we're taking a 5th root on both, oh, you don't see the problem yet. Okay, both of these involve the 5th root, so it wouldn't matter whether the variables were positive or negative anyway, because it's an odd root. Okay, I have a fraction. The numerator and denominator both have the same 5th root, so I can put them together as a single radical with 64x to the 8th in the numerator and 2x cubed in the denominator. Now I can simplify inside of the radical. 64 over 2 is 32. X to the 8th over x to the 3rd is x to the 5th. So I've got the 5th root of 32x to the 5th. 32 is 2 times 16, which is 2 times 2 times 8, which is 2 times 2 times 2 times 4, which is 2 times 2 times 2 times 2 times 2, or 2 to the 5th power. So that means that this is equal to the 5th root of 2 to the 5th x to the 5th. Well, what's the 5th root of 2 to the 5th? 2 outside. What's the 5th root of x to the 5th? X outside. Final answer, 2x. Any questions there? All right, continuing the chapter 9 review, this is problem number 11. It says simplify the cube root. So we have the cube root of negative 729 p to the 6th q to the 3rd. All right, negative 729, I could factor off that negative 1, okay? 7 plus 2 is 9, plus 9 is 18. 3 goes into 18, which means 3 goes into 729. So I'm going to go to my calculator. Remember to turn it on this time. 729 divided by 3 is 243. 243 divided by 3 is 81. I can take it from there. So this is negative 1 times 3 times 3 times 9 times 9. 81 is 9 times 9, which is negative 1 times 3 times 3. And then the 9 is 3 times 3. And the second 9 is 3 times 3. So I've got negative 1 times 3 to the 6th power. So I broke it down and then I built it back up using exponents. So the cube root of negative 1 times 3 to the 6th times p to the 6th times q to the 3rd. Notice, other than on the negative 1, that all of my exponents inside either match the index or multiples of the index. Well, first of all, let's deal with that negative 1. What's the cube root of negative 1? Or better yet, what's negative 1 times negative 1? That's 1. Times negative 1 is negative 1. So negative 1 cubed is negative 1. What's the cube root of negative 1? That's also negative 1. How fun is that? Okay, so the cube root of negative 1 is a negative 1 outside the radical. The cube root of 3 to the 6th power would be 3 to the what power? What's 6 divided by 3? 2. Any questions where I got the 2? All right. What's p to the 6th? What's the cube root of p to the 6th power? P squared. And the cube root of q cubed, the cube root of q cubed is q, which gives me negative 9 p squared q as my final answer. Let's see. Number 18 coming up next. We good to go? Any questions? All right, we're still in the chapter 9 review. This is problem number 18. It says simplify the expression. We have 36 over 49 all to the negative 3/2 power. And I'm looking at the answer that the person has, and their answer isn't wrong, it's just not finished. They just needed to keep going. But anyway, we'll take a look here. So the first thing I'm going to do is by taking the reciprocal of the base, that is the 36/49, that changes the exponent from a negative 3/2 to a positive 3/2. Okay. Now I'm going to apply that 3/2 to both the numerator and denominator of the base. Let's focus on just the top piece for a minute. 49 to the 3/2 power. So there's two things I'm going to do. I'm going to cube that base, and I'm also going to take the square root of it. As long as they both are real, I can do them in either order. I'm going to take the square root first because that will be easier to do. So basically, I'm going to take 49 to the 1/2 power and then cube it. 49 to the 1/2 power, that is the square root of 49, is 7. 7 cubed is, let's see here, 7 cubed is 343. So way back over here, my numerator is 343. Any questions about that before we go on to the denominator? All right, now let's focus on the denominator. I've got 36 to the 3/2 power. Again, I'm going to do the root and then the power. 36 to the 1/2 power is 6. And 6 cubed, let's see, 6 cubed is 216. So you've got that answer. All right. I want to talk for a minute about the answer that the student had. Okay, they had this. They had 6 to the -3 over 7 to the -3 power. And again, that is true information, but what is expected, even though it doesn't say that in the instructions, it just says simplify the expression, unless it tells you otherwise, you want to get rid of the negative exponents. Well, I could do that by taking this and moving it upstairs and taking that and moving it downstairs. And 7 cubed is 343, 6 cubed is 216. So the person that did this problem, your information was correct, you just didn't finish. All right, let's see here. We're gonna go on to another student, and now we are in, let's see, 4770. And there. Okay, and this is, we're back to 9.5. So this is back in 9.5, number 13. And again, if I already did this one, I don't think I did, but if I did with the same numbers, let me know. No, this doesn't look familiar. It says, solve the equation for the indicated variable. It says u equals the square root of 2gh, and we are to solve for h. So solve the equation for the indicated variable. On the right side of the equation, we have an isolated radical. There's no other terms over there. H is locked up inside of that radical. It's a square root, so we're going to start off by squaring both sides of the equation. That will give us u squared equals 2gh. All right. Now, I'm trying to get h by itself, so I need to divide both sides by 2g. So h equals u squared over 2g. And there you have the answer. Okay. Number 17 coming up next. Are we good to go on? All right, so this is still 9.5. This is number 17. And I'm going to show you this one because it's kind of complicated looking in terms of the description. 17. So it says, solve the equation, write all proposed solutions. If a solution is extraneous, so indicate. All right. So basically, you're going to go through, do what it takes to get answers, and then check them. If you come up with an answer, but it doesn't work, then that answer would be extraneous. If it does work, then it would not be extraneous. Okay. It says, let h of a equal the fourth root of the quantity a plus 13 minus the fourth root of the quantity 2a plus 5. So h of a equals the fourth root of the quantity a plus 13 minus the fourth root of the quantity 2a plus 5. It says, find all values of a for which h of a equals 0. All right, let's go back to the whiteboard here. So because they're telling us that, we're going to substitute 0 over here. So that means we have this equation. 0 equals the 4th root of a plus 13 minus the 4th root of 2a plus 5. Recall that in both absolute values and in radical situations, equations that is, if you have one absolute value or one radical, you want to isolate it on one side of the equation. If you have two of them, you want to separate them. So what I'm going to do now, I'm going to separate these two radicals. I'm going to add the 4th root of 2a plus 5 to both sides of the equation. So what that gives me now is this equation. The 4th root of 2a plus 5 equals the 4th root of a plus 13, because that would cancel out. Okay, so now I've got two radicals separated. What am I going to do to both sides to get rid of the radicals? What exponent am I going to use?
4.
Good, 4. Since we've got the 4th root, we'll raise both sides to the 4th power. That's going to give us 2a plus 5 equals a plus 13. So now we've got a nice first degree equation. I'm going to subtract a from both sides. I'll get a plus 5 equals 13. Whoops, equals 13. So a plus 5 equals 13. Subtract 5 and I get a equals 8. Okay, so a equals 8 is my proposed solution. Now, I'm going to determine, is it extraneous or not? Okay, does it work or not? Or does it not work or work? Okay, so I'm going to put 8 back in here and in there. Okay, actually, I'm going to put it in here and in there. So I'm going to recopy this on the next page. 0 equals the 4th root of something minus the 4th root of something. Let's see, we've got a plus 13, 2a plus 5. A plus 13, 2a plus 5. And we are taking a equals 8, and we're going to check to see if that's true. 0 equals the 4th root of 8 plus 13 minus the 4th root of 2 times 8 plus 5. 0 equals the 4th root of 21 minus the 4th root of 16 plus 5. 0 equals the 4th root of 21 minus the 4th root of 21. Now, I have no idea what the 4th root of 21 is. I could look it up, I could figure it out, but I do know it's real because we're taking an even root of a positive number. And I also know that the 4th root of 21 equals the 4th root of 21. Well, a number minus the same number equals 0. Therefore, 0 equals 0. So a equals 8 is the solution. And let me go back here to show you again what it looks like in WebAssign. So a equals 8 would be the solution. And then over here, it probably gives you a choice of extraneous or not extraneous, and it is not extraneous, which means it works. Okay. All right, any questions on that before we go on to the next one? Okay, so now we're going to go to the chapter review for this student. Let's see here, starting with number 16. So this is chapter 9 review, number 16. And again, if I've already done a problem, please tell me so I don't bore you to death by doing the same problem twice. Simplify the expression. All variables represent positive real numbers. We don't need to worry about absolute value bars. And we have the quantity 1/16 x to the 8th, y to the 8th, the whole thing to the 3/4 power. All right, if we have a product or a quotient or a combination of all raised to a power, we take that power and attach it to each factor in both the numerator and the denominator. So I get 1 to the 3/4 power over 16 to the 3/4 power times x to the 8th to the 3/4 power times y to the 8th to the 3/4 power. Okay, so we've attached that 3/4 exponent to all the factors in both the numerator and denominator of the base inside the parentheses. Let's take them one at a time. 1 to the 3/4 power. What's 1 cubed? 1 times 1 times 1 is 1. What's the 4th root of 1? Well, the only real answer is 1. So basically, I've got 1. Now, 16 to the 3/4 power. Let's do the root first and then the power. What's the 4th root of 16?
The 4.
2.
2. 4 times 4 times 4 times 4 would be too big, but 2. 2 times 2 is 4 times 2 is 8 times 2 is 16. So it's 2. And then cubed would be 8. Okay? You see that?
Yes,
Yeah.
makes sense.
Okay, good. And now let's take a look at this. Oh, a power raised to a power. We're going to just multiply the exponents. 8 times 3/4 would be 24/4 or 6. So that's x to the 6th. And then this 8 times 3/4 would be 24/4 or 6 y to the 6th. So I've got 1/8 x to the 6th, y to the 6th, or you could write it as x to the 6th, y to the 6th, all over 8. All righty. Any questions there? Still a chapter review. This is number 17. Simplify the expression. We have negative 125 over 8 to the negative 4/3 power. Okay, let me ask you this for a minute. What's the reciprocal of negative 2/3? What's the reciprocal?
3 over 2.
Is it 3 over 2 or would it be
Negative.
negative 3 over 2?
Negative 3
There
over
you go.
2.
Negative 3 over 2. Okay. So my point here is the reciprocal of this is going to be negative 8 over 125, but that's going to change the sign of the exponent to a positive 4/3. Okay. But the base is still negative. All right. In fact, I'm going to leave that negative sign attached to the 8 eventually here. So I'm going to have negative 8 to the 4/3 power over 125 to the 4/3 power. Okay. Focusing on the numerator, negative 8, I'm going to do the root and then the exponent. So what's the cube root of negative 8?
Negative 2.
Negative 2. And what's negative 2 to the 4th power?
Negative 8. Positive 8.
Positive, but you've got 2 times 2 is 4 times 2 is 8 times
Oh.
2 is, there you go, 16. Okay. All right. Now let's take 125 and the same thing. We're going to do the root first and then the exponent. What's the cube root of 125?
Hmm.
It's 5. Okay. 5 times 5 is 25 times 5 is 125. And what's 5 to the 4th power? Well, pull out our calculator, we'll find out it's 625. So there is our final answer for that problem. Okay. Number 19, still on the chapter review coming up. And it says simplify the expression 1 over 4 to the -5 power. So recall, if I have a base to a negative exponent on top and I move it downstairs, it makes the exponent positive. If I have a base to a negative exponent on the bottom, I can move it upstairs and it makes the exponent positive, which is basically what? 4 to the 5/2 power. Okay. Now let's deal with 4 to the 5/2 power. Let's do the root and then the exponent. What's the second root of 4? What's the square root of 4?
2.
And what's 2 to the 5th power? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32.
Hey, Mr. Mayo.
Yes.
So basically what you're doing is the number in parentheses, your timesing it times the exponent.
You talking about here?
Yeah.
I'm doing it that many times.
Yeah. Okay.
Yeah.
To get the 32, right?
Yeah. The exponent tells you how many factors of the base
Okay.
you multiply together. Yes. Okay.
Okay. Thank you.
You're welcome. All right, let's take a look. We're still in the chapter review. This is problem number 20. It says use a calculator to evaluate the expression. We have 50.5 to the 1/4 power, round to the nearest hundredth. So that's going to be point something something. So 2 decimal places over. All right, now what we've got to be careful of is when we apply the exponents, we're going to go 50.5 and then our little caret exponent thing. I'm going to go parentheses 1 divided by 4 equals. Because if I do this and I don't quantify that, it's going to just take 50.5 to the 1 power, which is 50.5, and then divide it by 4. And we're not dividing that by 4. We're taking the exponent and dividing it by 4. So 50.5, little power caret P, parentheses 1 divided by 4, close it up. And I'm getting 2.665771033, yada, yada, yada. Here's the hundredth place. The 5 would round up. So we get 2.67 would be the approximate solution. Any questions about doing that? Okay. And here's the last one that I got by request. I'll do that, and then I'll see if anybody has any other questions. This is still the chapter review, and this is problem number 22. It says, simplify the radical expression. Simplify the radical expression. All variables represent positive real numbers. So again, we don't have to worry about absolute value bars. Okay, our index is a 4. X to the 12th, 12 is a multiple of 4. Y to the 4th, 4 matches 4. So all I really need to deal with is the 32, which is 2 times 16, 2 times 2 times 8, 2 times 2 times 2 times 4, 2 times 2 times 2 times 2 times 2, 2 to the 5th power, which I'm going to write like this. 2 to the 4th times 2 to the 1 times x to the 12th times y to the 4th. So that's going to go out nice. That's going to go out nice. That's going to go out nice. What's the 4th root of 2 to the 4th? 2, outside. What's the 4th root of x to the 12th? That would be x to the what?
1/3.
Third. And the 4th root of y to the 4th is just y. And we've got the 4th root of 2 left inside. So 2x cubed y, 4th roots of 2 is our final answer. Don't forget to put the index in if it's not a 2, and don't forget to use the correct function key in WebAssign over there on the right. Again, I think I mentioned this yesterday. There's there's this thing that has a little box there, and then there's one that has little boxes here and here. If you use this one and put the 4 out there, it's not correct. That looks like 4 times something. So you've got to use this, and I believe that in WebAssign, there's a drop-down menu, and I think it says function or something like that. Anyway, I'm assuming that this person knew that because they got their index in the right place. All right, so I've answered all the questions people asked me ahead of time. We've still got a few minutes. Does anybody have any other questions they'd like to ask at this point? All righty, well then we will close up the session for today. And just a reminder of things I said. Your test will be Monday. No class on Monday. Finish your test by Monday night. No class Tuesday. It's advising day. So the next time, unless you come to my office hour this afternoon at 1:15, the next time we'll meet is Wednesday morning at 10:30.